Good morning, everyone. Hopefully you're all hyped up on Mountain Dew or coffee or whatever it is that keeps you going in the morning. My name's David Schloss. I'm here to talk to you about PowerShell. A little bit about myself real quick, though. I am the offensive security lead for Echelon Cyber and Risk. Basically, what that means is any of our emulation of criminal activity like red teaming, pen testing, web app testing, I run our company's section for that. I come from a red team background in the private sector. And then prior to that, I was in a special operations unit for cyber. So I got to do this stuff for fun. I have my LinkedIn up here in case you guys want to come check me out. I post red team and pen test tips every week, especially for October since it is cybersecurity month. And then I do have a Twitter, and it's at David Schloss, but all I do is post memes there. So if that's what you're looking for, that's available there. And just because we're a small company, I want to shout out our company real quick. We are a consulting firm in cybersecurity that does defensive, offensive, and advisory work. But past that, it doesn't really, not too important. So what's today's goal? Today, I want you guys to walk away with like this healthy dose of paranoia when it comes down to PowerShell. I think it's pretty important considering the fact that over the course of the last couple of years, we've kind of gone away from paying attention to PowerShell as a whole, as everyone started moving over to C# for their malicious binaries. So how are we going to do that? Well, first, we're going to talk about like why IT admins love it and why attackers love it, kind of set the stage, right? And then we're going to go into bypassing controls. Some of those are organic, like sign script execution, AMSI, and whitelisting. Some of them are not so organic, like an EDR's enumeration alerts. Then we're going to wrap it up with some malware deployment and a few tips on how you can protect yourself. Let's jump into it. So why do admins love it? Quite simply, it's everywhere, right? It's on Windows, Linux, Mac. I've had it on my Mac machine. I've had it on my Linux administration machines. It's perfect. It has a really wide market share, and it works across the board. It's easy to use and learn. This is actually one of the first applications or programming languages I learned, or scripting language, I guess in this case, even for Python. And lastly, it enables more functions around remote administration. I originally started my career as an IT admin, and PowerShell was taking functions that would normally take hours down to just a couple minutes to run. So why do attackers love it? Well, frankly, it's everywhere, right? Windows, Linux, Mac. You can put it on your Kali Linux machine and just negate the need for Impacket to interface with a Windows machine. Easy to use and learn. Everyone likes to bash on Microsoft, so there's a ton of resources out there for offensive security PowerShell scripting, right? And then it enables more functions around remote administration. Quite frankly, when you look at it this way, it really shows that the attackers have an advantage. I think what a lot of people just don't seem to realize is that if you gain access to PowerShell, you can just run scripts from memory. You can copy paste into the terminal. You can import it via net web requests. There is actually no need for scripts like Mimikatz from PowerShell or PowerView or any of that stuff to be on disk. So it makes it very difficult for like signature-based AVs to detect this kind of activity. Additionally, it's scriptable.net. So this is the reason why we saw a lot of people go from PowerShell over to C#, because it's basically the same thing. And we'll get more into that later. And then again, organic security functions are always getting defeated. People just love to shit on Microsoft for some reason. So they find new ways of doing it. Quite frankly, like in about 95% of my engagements when I was still running as a red teamer, PowerShell was the major factor in how we gained code execution or privilege escalation, lateral movement. Just by it being there, you open up a lot of avenues for attack from a threat actor. So let's jump into some of the cool stuff now that we've kind of set the stage. The first one is it's going to make some of you attackers out there roll your eyes, and that is sign script execution. And the reason why the attackers are rolling their eyes right now is because this is not a security control. But I bring it up here because a lot of my clients believe this is a security control. And if you read the documentation from Microsoft, they write it as it's a security control. For those who don't know, script signing execution is just a policy that's placed into PowerShell that will force the scripts that you're running to be signed or unsigned or self-signed, right? And the reason why people think this is a security control in itself is that when you try to set execution policy, which we can see in the screenshot, to bypass, it actually says, nah, you can't do that, right? Especially if you're a low privilege user. But the reason why this isn't like security control is this right here. It's quite simply easy to bypass by just executing PowerShell with the flag EP or execution policy and then bypass. And then you have a nice little bypass terminal. And something to note, though, is that is only for this terminal, right? When you're doing the code execution of set execution policy within PowerShell, you're trying to change a registry key in the HKLM Hive. But when you just run PowerShell exe, tech EP bypass, then you're just setting it for that one-time terminal. So if you close out of PowerShell, it won't affect any other terminal on the system. But it helps. Again, I just wanted to throw this out because it's really important. Don't treat this as a security control or stop treating it as a security control. And that brings us into the cool stuff. And this is going to be what a majority of the talk is going to be about, which is bypassing AMSI. So AMSI, or what I call AMSI for short, is the anti-malware scan interface. It is a known good hook into PowerShell and other scripting languages within Microsoft for security products to use so they can monitor execution in like Office macros, Windows script host, things like that. In PowerShell itself, it additionally will try to block malicious scripts and functions. So the IEX new object download string, which is probably the most commonly used command to import malicious scripts into your network, is just flat out blocked. Like AMSI goes, nah, this is too dangerous. Additionally, strings like Mimikatz, Bloodhound, PowerView, even itself, AMSI utils is considered malicious in its eyes, and it'll block you from being able to execute if it sees those strings. So it's kind of nice. Some known integrated antivirus applications here are like McAfee, Sophos, Kaspersky, Windows Defender, kind of a duh there. There's probably more. I really didn't dig too deep into it, to be honest with you. But these are the ones that are openly admitting that they use AMSI as part of their tool. So here comes another really fun, easy bypass. PowerShell 2.0. For those who don't know, PowerShell 2.0 is installed by default in even the newest versions of Windows 10. And it has absolutely zero security functions, which is why when you look at like Matt Graber's PowerView or other Windows enumeration scripts, they'll usually try to downgrade to PowerShell version 2.0 really quickly or right off the bat, because then you don't have to worry about any of the security controls or script block logging and things like that. Though to caveat all that, .NET version 2.0 is required for PowerShell 2.0 to execute, which doesn't come by default. But if you're running old applications that require like .NET 3.5, then .NET 2.0 is bundled with that for some odd reason, which is kind of weird. But this is really easy to downgrade to. In fact, all it takes is a quick little screenshot. I don't even have to show you a demo of what's going on. And the first command up at the top, we're running PS version table to show you that we're running PowerShell version 5.1. And then we're trying to echo AMSI utils. This is like a test that we as attackers will use to see if AMSI is still working. And you can see that it doesn't like itself being called, so it goes and blocks it. But then you could just call PowerShell.exe tech version 2, and then, oh, cool, now you can echo AMSI utils, right? So stupid simple and is actually like very widely used and is still widely available because most people don't realize that it's just sitting there, right? So what can we do if PowerShell version 2.0 isn't available? We need to find some way of crashing it, right? So this comes to the fun part of where we're going to get to and why I think PowerShell is still so dangerous. And when we left it or stopped paying attention to it, it just kept working, or our attacks kept working. So when we want to defeat AMSI, what we're trying to do is put AMSI into a failed state. The reason being is AMSI doesn't have a self-recovery function, meaning if you somehow set it to crash and you get the field AMSI and it failed to set to true, it'll just stop working. It doesn't try to reload itself, which is cool for attackers. It's really bad for defenders, right? So back in 2016, Matt Graber, the genius of PowerShell, found that you could use reflection to just call the AMSI and it failed field and set that to true. And this is the reason why AMSI utils is actually a banned string within AMSI, thanks to Matt Graber. And this was fixed relatively quickly. The problem is this line below it where you have the concatenated strings of AMSI utils and AMSI and it failed. Well, that worked all the way up until 2020. I was using that on most of my red teams up until last year, right? That's kind of scary because they state in their documentation that AMSI does concatenate before code execution, which just wasn't true. But this is actually a really good use case into showing you guys that Microsoft really didn't fix the issue. They just kind of pushed it to the side. And we're going to step through that real quick, right? So the first thing that we needed to do here was figure out, we need to set the static, right? So we need to call AMSI utils and make sure, okay, yeah, it is blocking it. And then we needed to see, does concatenation still work, right? So can we call AMSI utils with it concatenated out? And we can. So that begs the question, all right, how deep down the rabbit hole do we need to go before Microsoft says this is malicious? So the next thing we need to do is figure out, okay, can we just call the field? Can we call AMSI and it failed? And it turns out you still can. You can concatenate it, and as you can see in the screenshot below, we do get all the information from AMSI and it failed. So something weird is going on that isn't as straightforward as most attackers would think. Well, what it turns out is, and thanks to Secure This Shit for writing up a great write-up on what's going on here, but when you call a field and then you set the value, AMSI does a little bit of regex from that and then goes, okay, I see a few things that are matching up. I'm going to concatenate the strings within the get type and get field. And if they equal a malicious string, then I'm going to obviously block it. So it's kind of cool because now they're thinking, okay, maybe if we do some regex, we can catch this stuff. The problem is AMSI still sucks. My number one rule when defeating just about anything in PowerShell is when in doubt, encode it out. I would avoid base64 as a whole because it is a organic command structure within PowerShell. But what you can do is format to hex. And so in the two screenshots below, what you're seeing here is the concatenation of AMSI utils formatted into hex on an encoding of UTF-8, and we can print it. We get our nice little hex code over here to the left. And then when we do the same thing for AMSI and it failed, we get this nice little hex code again. So from there, we have to create a one-liner to figure out how to turn our hex back into text, right? Because we already have our text in a hex. So you get a sweet little like Dr. Seuss rhyme there as well. So the one-liner is quite simple. All we have to do is split each individual character and then convert it back into a character, right? We take the hex code and we split it into a character, push that into a result field, and that result field then prints AMSI utils. So what does that look like? Quite simply, it's using Matt Graber's method with hex. So the first thing we print out is AMSI util, show you that it is functioning. AMSI is functioning. We print in our Matt Graber method with our hex code and our single line for breaking apart or breaking back into text for both AMSI utils and AMSI and it failed, setting that value to true. And now we can call AMSI, showing that AMSI has been defeated using this method. So this 2016 method really still hasn't been fixed, right? And I can tell you this is probably one of my more favorite ways of showing clients that they're not as secure as they think they are just because they have some organic controls. The next piece, and I wouldn't worry about writing any of this down, is the Rasta mouse method. Ooh, it's a tongue twister. The reason why I wanted to call this one out in particular is because this is kind of an interesting way of doing it. Rasta Mouth actually found that you could patch the loaded DLL. And that's kind of scary for people who are attackers, or even those who run EDRs, because if you're able to patch the loaded DLL, you could possibly unhook the DLL and load in something that's clean from your EDR or from kernel 32 or NTDLL 32, right? And this is just C# code that's running in PowerShell. The only caveat I would say is when you run this kind of code is if you're an attacker, don't use add type, because add type leaves a temporary DLL on disk, and it's an artifact, so you can get caught from that. But basically all this is doing is loading in the AMZ DLL. It's finding the scan buffer library, and then it's overwriting the first couple bytes. And the reason being is when AMZ calls itself in AMZ scan buffer, AMZ context, AMZ init failed, it always looks for the first couple bytes that are static. And those static bytes translate to like AMZ. So it's just looking for like the first 4 letters of its name. And if it doesn't see that, then it goes, oh, I'm corrupted, set it to failed, and you're good to go. So this is a relatively old method as well. I didn't do any obfuscation on this one. And as we can see, AMZ utils is running. I'll eventually copy and paste it in. Nothing's coming up from AMZ. We're able to load in our C# code and call AMZ again, right? So this is a really relatively old method as well that just still works right out of the box. Nothing has really changed in this way of doing things. The only difference is, I think, if you ever saw this in the wild, it would be, oops, I am scroll wheeling. All right, I totally screwed that up. Give me a second. There we go. The only thing I would say, if you saw this in the wild, it would be done using like Matt Graver's method or the offensive security method for loading in DLL imports. So it would be reflectively loaded in, so you're not putting anything on disk. But for the most part, this technique still works, right? There is one other one that I kind of want to go over real quick, and hopefully you guys can still see my screen. But it's the offensive security method, which is right here. And the reason why I like the offensive security method a lot is this particular method reflectively gathers all the assembly types that are loaded into PowerShell, and then it uses wildcards on like iutils and context to find the address and then overwrite the address of AMZ context. So if we just type in AMZ utils again, show that it's blocked, and copy in our script, again, it's going to allow us to print it. But what I think is kind of cool here is we can actually kind of go out and look at each individual section. So when we type in gather, we can see all of the loaded function types or assembly types that are loaded in. And maybe I just cancel it. There we go. Yep. And we can kind of step down and see like where each piece of this is going. So when we pull up Delta, we can actually pull up all the functions within the AMZ DLL, AMZ context, AMZ session, AMZ init failed, AMZ lock object. And what I think is super cool about this is we can actually pull the address for AMZ context, right? So if we pull up context here, we can, oh, actually it's gonna pull up the wrong thing, but adder will work in the same way. So when we call the address variable here, we can actually see the memory address that it's dynamically loaded into, and then that's what we're copying over using .NET, because .NET is available to us in PowerShell. This is a very nice like red teaming little 8 lines of code because it's very hard to detect and see. At least I haven't been caught in that regard from it. But I just wanted to point that out real quick before we continue. So what happens when you can't run code to bypass AMSI? Whether that's through restricted language mode, like restricted or constrained language mode, or app locker, application whitelisting, blacklisting, whatever you're trying to do. Well, quite simply, PowerShell is just a bunch of loaded DLLs on top of command prompt. That's why it's called PowerShell, right? So you can just quite easily create your own PowerShell using living off the line binaries. Or you can be lazy like 90% of us in the pen testing and red teaming world and just use this wonderful program called MS Build Shell, which can be found at the GitHub. And what MS Build Shell does is it uses the .NET version 4.0 executable MS Build, I think it's MS Build, to build a CS project file. Yeah, here we go. So because .NET 4.0 is installed by default, msbuild.exe is also a living off the land binary. It is installed by default. The first thing I did here is I wrote up PS version table so you guys can see that it's not running PowerShell currently. This is just a straight command prompt. But what we can do is we can take this CS project file, which doesn't get flagged by antivirus programs because in itself, it's not malicious. And if they started flagging on that kind of activity, you would potentially start flagging on legitimate activity. But very simply, all we have to do is hit enter here, and it builds us a shell. The errors that we see coming up is the application trying to disable AMSI. Quite simply, it's the old Matt Graber's method. You could just edit the lines of code that are in there, and then this would come up as, or nothing would show. But I left it in just so you can see what it looks like as the default. But now we can run PS version table, and we get a PS version number. But when we look at the top here, we're not running PowerShell, we're running MS Build Shell. So when you look at that from a perspective of application whitelisting or blacklisting, like this is not going to get caught. The only functionality that you would lose inside this terminal would be your tab functionality that comes with PowerShell. But I mean, that's no big deal. And then I think I just exit out of here. Yeah, just so you can see, it shows as a build, exits. It doesn't actually leave anything behind. The only thing that would possibly be needed on disk is the CS project file, or you could host that at a distant SMB server, and it would still function the same way. There are other ways of doing this. I kind of don't want to get too deep into it because it would be a little bit more outside the scope of PowerShell, but there are other projects like PowerShell DLL project, which you can run the many different living off the land binaries to run a DLL. There's my personal favorite, which is the Sync App Publishing Server, which is a script that's given to you by default. You can break out of that and send a request to a distant server, be that your attacking server, and you can use Netcat to capture it, and you'll get a sweet PowerShell shell from that. If you want to learn more about this stuff, I would definitely check out like iRed.team. They have some great write-ups on using PowerShell without having to use PowerShell. And then the last thing on bypassing alerts is going to be enumeration alerts. This is something that I think is more red team focused, but it is kind of an interesting way of looking at things. EDRs have gotten really smart on being able to detect the heuristics of an attacker enumerating a doc or a workstation. And the reason being is because most people just run like JAWS, which is just another Windows enumeration script, or other enumeration scripts that just call ipconfig, whoami, netstat, netsh. But those are all applications that are built and listed in System32. So if you go to System32, you'll see them quite obviously. We'll come back to our PowerShell screen here so you can kind of see what I'm talking about. But if we type in who am I, right, we get this nice little call out. Well, if we don't want to use those System32 executables, we can use .NET from PowerShell to build our own who am I. using environment variables and .NET calls. So in this case, whoami turns into environment user domain, environment username. And it looks pretty much the same with some better capitalization where it would normally be seen. Though when you start doing things like ipconfig, this is nice and neat, very cool to look at. The .NET library for this doesn't look as pretty. What did I screw up? Uh-oh. Oh. There we go. So it's not as pretty, but it does get you the information, right? And you can use PowerShell to format out these strings to make it pretty. You know, say you want the OS build version. Oops. You can pull the OS version, push the system environment for OS version into a variable, and then pull out version and build. And now you have the build version of the application itself. And then, you know, there's some fun things that if you really want to get down to it, like you can print out which EDR or antivirus system you're using, as long as I didn't screw this up, and format that out. And because Windows keeps track of most of that activity, you can just print it out. But this is stuff that won't necessarily get you caught. Well, this EDR information might, because you're going to call a CIM instance. But the other ones are using system environment variables and .NET, basically pretending to be like an installer. So if you can change up the way that you call things, you start defeating the way that these EDR products are detecting enumeration, which allows you to live on the machine for a lot longer. Right, this is just a screenshot of the same thing. So we talked about all of that just to get to malware deployment. This is the fun stuff. Basically, with malware execution on PowerShell, all you have to do is take your C# code and turn it into PowerShell code, vice versa. It's .NET, right? To get basic code execution, you need virtualELEC and create thread from kernel 32, and you need the Marshal service to copy your shellcode into the allocated memory. And then you do still have to do some AV avoidance, like reflectively calling your DLLs and a little bit of shellcode obfuscation, just because you're creating a new thread. So what I think is cool about malware execution is that if you're using the Matt Graber method, which I think is the best for beginners in pen testing and attacking using offensive PowerShell, the top line of code for where we're importing kernel 32's virtualELEC is from pinvoke. And the one right below it is how we would import it into Matt Graber's method. It's quite simply the same, just a little less information. You know, you're still calling out, hey, I need it to be an int pointer or integer pointer. I need an unsigned integer, all that jazz. And then when we want to call it, it is pretty much exactly the same, right? This is how you call it in C#, and this is how you call it in PowerShell. Very simple, straight to the point. Another thing that's really brilliant about PowerShell is it helps out with shellcode obfuscation, right? And it is still necessary. You don't want to put just like meterpreter shellcode on a in a variable and just call it a day. Somebody's going to catch that. But PowerShell reads bytecode as decimal instead of hex, which is perfect if you like messing around with numbers. I'm not too much of a fan of hex code and trying to format hex when you start doing obfuscation. So like 0x00 becomes 000 and 0xFF becomes 255. And say you want to do something simple like a Caesar cipher, which is pushing a byte to the left or to the right. In this case, in this example, we're pushing the byte 5 to the right. 000 becomes 005. 255 becomes 260. But because 260 is over, byte's maximum range, we need to use another function within PowerShell, which is given to us quite nicely as modulus, right? It's a mathematical function, and the operator is the %sign. So say you're trying to set your offset to not go over your 255. You just do 256 minus or plus your offset, and then modulus that by 256. So then 000 becomes 005, and 225 becomes 004. Very, very simple to work with, especially when you're doing a Caesar cipher. So what does that all look like? Basically, what we're going to do here is we're going to run our multi-handler as a Meterpreter reverse HTTPS, and we've already pre-encoded it with a Caesar cipher of 66. So I'm showing you, oh shit. Let me not click the wrong buttons here. So what I'm showing you first is that PowerShell is running under 11.496, just so you are aware, because we're going to execute within this process, and that AMSI is currently running. And we've talked a lot about just copying and pasting things into a terminal if you have access, but say it's like a ton of code and you don't want to just sit there and wait forever. What you can do is use .NET web request to create a new web request and read that into a variable. So if there are any people out there that want to utilize this code, please do. It's quite fun. It functions just like how Internet Explorer would, minus you're not reading into a variable on Internet Explorer. But the cool thing here is once we have it into a variable, we can just execute that variable with IEX content. So we're not directly writing it into the PowerShell application at first. Then we're going to call invoke bsides because that's the function that I called it. Give it a supplied offset of 66. One thing to note here is that there is an antivirus running. Nothing has popped up. And we can call back and we see that there's a session running. The UID, the PID, 11.496. The UID is the low priv user that we've been using for all this time. And I think that wraps that part up. Yeah. I have a much longer explanation of this code too that we'll be releasing a little bit later. Just in this case, the time limit kind of constrained this. So now that you're hopefully a little bit paranoid, like what can you do? How can you fix some of these things? Quite simply, like my number one thing is always to disable PowerShell. You wouldn't give your users Python, so why would you give them PowerShell? I get this doesn't work for everyone, but what people seem to forget is that GPOs do allow you to apply like these application blacklisting or whitelisting to specific OUs. So your administrators can still use PowerShell. I would just limit it for the users. Also look at expanding your application blacklisting. You know, not everything Microsoft provides you is safe. DDE Auto is a prime example of this. Definitely use some AI-based security products because they are going to hook into kernel 32 and to NTDLL. And like I had mentioned, like, sure, you might be able to unhook it within PowerShell, but with a better AI-based security product, it is going to be able to detect when a sensor is being bypassed and alert you on that activity. And then last but not least, and this is less for the people in the room, but Microsoft kind of has to fix their stuff, right? I can't say it's just a feature anymore. There is a lot of issues and vulnerabilities within PowerShell that have been functioning since its release. And because we've started to focus more on C# binaries and other attack vectors, people just forgot that PowerShell existed. And they left it at, oh, we have constrained language mode, or we have script signing execution, or we have AMSI, right? They forget that this is the majority of the way that attackers get into your network and stay here. Fileless malware attacks utilize PowerShell. Yeah, it might be through your registry, but it's still calling PowerShell. So any ways that we can start refocusing on these attack vectors using the application would be beneficial to the security community as a whole. So that's my talk. Here's my information again for anybody who wants to jot it down or wants to download these slides from our webpage.